Alright, hello. This is a tutorial video showing you everything that you need to know to get set up with your own Proxmox container. I will be showing you how to create your own container via the terminal, how to log into the Proxmox web GUI and navigate around there, and finally, how to open up your container in a remote session in VS Code. Hopefully, by the end of this tutorial, you'll know everything you need to know to get set up with your own Proxmox container or containers. So let's get started. Right now, I am in my browser. To log into the Proxmox web GUI, you're going to type in opensource.mieweb.org:8006 as the port number is 8006, and you're just going to type enter. Once the page loads, you'll be prompted for your username and password. Either me, Carter, or another administrator will have already set you up with a username and password. If we have not already, please reach out to us and we will do that for you. So here, I'm just going to enter my login credentials and my password. For the realm, as of recording, July 2nd, you're going to select Proxmox VE Authentication Server. However, we are in the process of migrating to an open source LDAP server. Once we migrate, we will let all the interns and developers know, and at that point, you will select the open source LDAP option. But for now, just select Proxmox VE Authentication Server. I recommend saving your username and password for seamless login in the future. Once all of those credentials are entered, press Login, and you are now logged into the Proxmox web GUI. The first thing you might see is this no valid subscription box. You can just ignore this by pressing OK. And here you are. You're now entered into the Proxmox web GUI. On the left side, you'll see two different hypervisors, PVE1 and PVE2. These are our current hypervisors in the system. Both of these computers are Dell PowerEdges, capable of handling both a lot of virtual machines and Linux containers all running at the same exact time. This allows us to host multiple containers across the company. In the near future, we will be adding our AI computers to this cluster, allowing developers and interns alike to train their own models or carry out any computations that require a lot of GPU usage. But for right now, we just have these two hypervisors, which is sufficient. When first logging into your account, expanding these two nodes, you won't see any containers. That's okay. When we create a container, all of that information will show up here. So the next step is to actually create a container. So how do we do this? To create a container, you're going to open up your local terminal window and perform an SSH command to connect to a remote host hosted inside of one of our hypervisors. This host comes with a script that will automatically run, allowing you to create your own container. The SSH command we'll be using is SSH create, all lowercase, -container at opensource.mieweb.org. Ensure everything is spelled correctly, and once you've done that, press enter. It might take a second or two to load. But once you've done that, you'll see the start of the container creation script. It is important to note that if you're doing this for the first time, you may be prompted a few times to enter a password. This password is all lowercase, MIE, then the numbers 123, and then an exclamation mark. That's MIE 123 exclamation mark. I'll show you pretty soon how you can bypass this in the future using public keys. Once we're in the container creation script, the first thing we're going to do is enter our credentials. These are the same credentials that we've used recently to sign into the Proxmox web GUI. So I'm just going to enter my username and my password, and then I will be authenticated. If you enter any of your credentials incorrectly, you'll be asked to try again. After 3 or 4 incorrect attempts, you'll be automatically logged out of the remote session, and you will have to log back in to try again. The next step is to enter our application name. Choose your application name wisely, because this is the host name that will show up in your domain. For example, if my host name is maxapp, then my domain will be maxapp.opensource.mieweb.org. You can name it after your username, or, as I recommend, name it after your project or your application so users are more easily able to identify what the container is. But since this is just a demo, I'll just enter maxapp7. Make sure it's all lowercase and that you have no spaces in the app name. Once that's done, I'll press enter. If the app name is available, meaning no other users have created a container with that same hostname, you'll get a green check mark. Otherwise, you'll be asked to try again. The next step is to enter your container password. This password is different from your Proxmox credentials. The difference between the two is that your Proxmox account is used to manage anywhere from 1 to n number of containers. However, each container can have its own credentials. You can apply the same credentials to each container or have different credentials for each container. The choice is up to you. But the username for all the containers is going to be root by default unless you add other users later. The password must be at least 8 characters, so keep that in mind when creating your password. It's going to ask you to confirm, and once you've confirmed, you'll be prompted to the next step. The next step of the container creation process is the most important. It's going to prompt you for a public key. This public key will be used to automatically SSH into your container without being prompted a password, making it a lot more secure and faster to gain access to your container. If this is your first time creating a container with this script, the script will not be able to automatically detect your public key. You'll be prompted to enter that manually. To find your public key, go to your home directory on your local machine and then cd to the .ssh hidden directory. Once you're inside there, you should see an option for a public key file, whether that's RSA, ED25519, or another encryption algorithm. If you do not have any public keys on your local machine, that's okay. You can use the SSH-keygen algorithm to generate your own local private public key pair very quickly on your local machine. Once you identify your public key file, simply copy the contents of that public key and paste it in the prompt. If the public key's format is valid, it'll accept it and you will be asked to move on to the next step. Now, you may see on my screen that the script automatically detected my public key. Well, this is because this is not my first time creating a container. Once you've entered your public key for the first time, you will not have to do that in the future. Our cluster will automatically detect your public key the next time you log in, skipping this whole process. Once that's done, it's going to ask for our HTTP port for our container to listen on. This can be anywhere from 80 to 9999. For most containers, I would recommend 3000, but if your container needs to listen on a special port, that's okay too. So I'm just going to enter 3000 here. Great. Our HTTP port is set to 3000. For most people, you can skip the next step. However, if your container requires special protocols other than SSH and HTTP, you're going to want to listen to this next step. If this applies to you, you're going to press the Y button for yes, and it's going to prompt you for the protocol abbreviation to enter. If, for example, I need to use FTP on my server, I'm going to enter FTP, and it's going to add that to my container. Additionally, if I'm using a database, I may need to use a special protocol, such as with MongoDB and the Mongo protocol. If that's the case, I will just enter Mongo, and it'll also add that to the container. You can add as many protocols to your container as you'd like. Our cluster has a master list of over 200 different protocols to choose from. The program will tell you if you enter a protocol that's not on our master list, and it'll tell you if your protocol is valid and if it's added. If you need a protocol that's not on the master list, reach out to one of our administrators or myself, and we will add that protocol to the master list. Once you've entered all the protocols that you've needed, you're going to press E for exit, and the script's going to continue. At this point, the program's all autonomous. As you see right now, the script is cloning a Debian template and applying that to your own container, allocating resources such as RAM, CPU, and disk memory. The script also uses DHCP to automatically allocate an internal IP address to your container. It's also going to install some packages automatically, such as sudo and git, so you can easily get up and running and clone your repository in your container. At some point during the program, you'll see a list of different port numbers. These are very important, and I highly recommend you to copy these down somewhere where you'll remember them. The most important port number is your SSH port. This is the port you'll use every time to SSH into your container. If you added any additional protocols, like in my case where I added Mongo and FTP, you also want to copy those port numbers down too. At the very end of the container creation process, you'll be given a summary of all your container details. You can see your container ID, the internal IP address of your container, your domain name of your container, and then the SSH command to SSH into your container. And that's all. Your container has been created. So let's check it out. If you navigate back to the Proxmox web GUI, you will see that under PVE2, I now have a new container that shows up in the GUI. It has the same hostname that I entered in the script, maxapp7, and it's even tagged with my own username. By clicking into my container, I am able to see all the metrics. I can see the total uptime, which is the amount of time that your container has been up and running, the CPU usage of your container, the memory usage, the swap memory usage, and the SSD usage. Initially, these metrics should be very low. Proxmox also provides graphs, so over time you can see exactly how much usage of a certain metric or a certain resource that you're using. If your container is a little more resource hungry, such as a Meteor application or any application running some sort of server like an MCP server, your container might need more resources. If that's the case, again, reach out to me or another administrator and we'll be happy to allocate more resources to your container. But by default, these resources should be enough to get up and running. Okay, so now we've created a container. We're able to view the metrics of the container. How do we get access to the container? Well, as you saw in the output, you can see the SSH command right here. So if navigating around the terminal is more your thing, you can simply copy and paste this command into a new terminal window and you'll have direct access to your container. However, if you're more like me and you prefer to use an IDE, such as Visual Studio Code, to manage your code base and push and pull from GitHub, I'm going to show you how you can remotely connect to your host in Visual Studio Code by creating some different configuration settings. Once you have your Visual Studio Code open, you're going to want to make sure that you have the remote SSH extension installed. If you don't, you can simply go to the extension marketplace provided by Visual Studio Code and install that extension. For reference, this is what the extension will look like. Once you've successfully installed that plugin, you'll be able to access it on the left-hand side of your Visual Studio Code window, and it'll be shown as a computer icon with a code symbol. Clicking that, you'll be able to see a list of your SSH hosts. If you're installing this for the first time, you're not going to have any. If you used this before, then you'll see a list of hosts that you've previously connected with. To connect a new host, navigate to the very bottom left-hand corner of your Visual Studio Code window. It's this little icon with two caret symbols facing each other. Click that, and then click Connect to Host. Go to Configure Hosts, and then click on the file that's already selected. This is your SSH configuration file. In this file, we'll be adding our new host. To do this, you're going to type in host on a new line, followed by the name of your host. The name of this host can be anything you want. It does not have to share the same name as the container that you just created. However, I recommend using the same name as your container, just so you'll be able to easily recognize it. So I'll just type in maxapp7. For the next field, on a new line, tab indented, we're going to enter our host name. This is just going to be opensource.mieweb.org. On the next line, we're going to enter our user. This is just going to be root. Lastly, we're going to enter our SSH port. In my case, my port was 2262. So I'll enter that here. And that's it. These are the only settings that you'll need. Once you've saved this file, on the left-hand side, you'll be able to see this new host added. If not, just hit this refresh button and it should show up. Once you see the new host added, you can use this arrow to connect in the current window to your remote host. It's going to ask you to accept the fingerprint of your remote container. Since I'm SSHing for the first time and I know it's my container, I'm going to hit continue. If you have not used a public key when creating your container, it's going to then prompt you for your container password. If not, and you've entered the correct public key, you should automatically have access to your container. Once you've successfully connected to your remote container, you'll see the familiar VS Code welcome screen. While it may look like we're on our local machine, we're actually in our container. If you go to this file icon and click Open Folder, instead of seeing folders from your local machine, these will be folders on the container. Navigate to the root folder and click OK. It's going to ask you, if you're doing this for the first time, to trust the authors. Since you're the author and it's your container, you're going to obviously hit yes. Once we've opened that folder, you'll be able to see all the folders and files inside the root directory, including your public SSH key if you have added that. The last thing I'm going to show you in this tutorial is how to clone your repository and get it up and running on your domain. To do this, I'm going to open a new terminal window. On my web browser, I'll open the repository that I want to clone. I'll go to the code button, and then here it'll give me the link to clone my repository. Then I'll navigate back to my container in my VS Code window and type in the command git clone, and then paste that repository link. Right now, it's going to clone into Rank Room. Once I've cloned that repository, the next step is to navigate to that folder. I'm going to hit File, Open Folder, and then I'm going to type in root again because I cloned it in the root folder. And then I'm going to enter the name of my project or the GitHub repository that I just cloned. Then hit OK. And now you will see just your GitHub repository files on the left-hand side. Now it's time to actually get this application up and running. Now, everyone's application is different. Depending on how you run your application on your local machine will dictate the next steps. If you're using any sort of JavaScript library or framework, chances are you're going to need to install Node.js and npm for the package manager to install all of your dependencies. So I will write the command apt install Node.js, with Node.js being all one word, lowercase, no spaces or hyphens. Hit enter to continue installing that. Once that's been installed, I will next install npm. And like before, I'll let that install. Once npm is installed, or any package manager that you need to install your dependencies, the next step is to actually install those dependencies, listed either in a requirements.txt file if you're using pip or Python, or a package.json file if you're using a JavaScript framework with npm. In my case, because I'm using a JavaScript framework, I'm going to use npm-i to install all of my project dependencies. Once those are all installed, I'll see a node modules folder, so I know that my packages are installed. At this point, it's also important to note that if you have any environment variables that you've been using on your local machine but have not been pushed to your GitHub repository, you're going to want to add those now, since these will be essential for running your application. In my case, I do not have any environment variables that I need to use, so I'm going to skip this step. Finally, I'm going to configure my repository to run on the HTTP port that I assigned in the container creation program. Going back to my container creation output, I can see that I assigned an HTTP port of 3000. So I'll use that in my project. Right here lists the port that my project is listening on. So instead of 32,000, I'll switch that to 3000. Also, if you've added any additional protocols, make sure to update those accordingly. Now, I'm ready to start my server. For me, I'm just going to look at my package.json and see that to start it, I'm going to run npm start. So I will click that, and it's going to start the server. It's going to listen on port 3000. And if I've set everything up correctly, I should be able to open my web browser and navigate to the link of my container. In my case, it's going to be max-app7.opensource.mieweb.org. Once I navigate to the public domain of my container, you can see my project right here. In this case, because I'm hosting a web app, you're able to see the web app. I'm able to interact with it like I normally would on my local machine. And if I'm using a database, which in my case, I believe this is using Mongo, I'm able to communicate with that as well. I can also try registering a new account on this application, just to make sure my Mongo database is working. And it seems that it successfully created a new account. If I go back to my logs, I can see my new user ID here. It is important to note that some dependencies for your project may need to be installed container-wide instead of just locally in your repository folder. To do this, it really depends on what type of service you're trying to install. However, for any service, I recommend going online and reading the documentation for installing that service on Debian. You can also use a chatbot, such as ChatGPT, to quickly search how to install your service on Debian 12. Once your service is installed, you can start the service by using the command system control start and then the name of your service. In my case, my service is MongoD, so I'm going to start that. To check if it's running or if the service failed, you can run system control status and then the name of your service. So I'll check my MongoD service, and I can see that it's active. If the service failed, you can always check in the logs of the service using journal control -u, and then the name of the service, and then /f. It'll show you what exit codes the service failed with to help you debug the issue. That's about it for this video. Hopefully by following along, you're able to create your own container using a terminal and SSHing into that create container script, and you're able to access it via the web GUI, your terminal, or in VS Code, and you're able to clone your GitHub repository to quickly begin work. It may take some time to set up all your dependencies, services, and port mappings to make sure your container is up and running successfully. However, once it is, you'll now be able to access it using a public domain hosted on MIE's own internal servers. Thank you for watching. If you have any other questions, please feel free to reach out to me. Thank you.